In this lesson, we're going to look at proportions and their applications. So let's start out with what a proportion is. It's a statement that two ratios are equal to each other. So remember, a ratio is comparing two numbers using the same units, and then a proportion would be comparing two ratios, sort of like comparing two fractions to each other, same idea. So for example, if I had 6 to 12 is equal to 36 to 72. 6 to 12 is one ratio. Sorry, I just got ahead of myself with the highlighting. But here's one ratio, and here's another ratio. Okay? So there's ratio 1, here's ratio 2. So those are the two different ratios. Now what I started to do with the highlighting was just to show how the 6 matches up with the 36 because they're both the first numbers in their respective ratios. The 12 matches up with the 72 because they're both the second numbers in their respective ratios. And in particular, 36 is 6 times 6, or 6 times 6 equals 36. And 12 times 6 equals 72. So again, each part is the same, in the second ratio, it's just a multiple of each part in the first ratio, just like equivalent fractions are similar in that way. Now, a proportion consists of 4 different terms, and in many situations, 3 of those terms are known and the 4th term can be calculated. So in other words, just like in any math problem we want to solve, often there's a missing piece that we can then calculate. So what we want to do is we want to get equivalent ratios and then use that, find out what the multiple is that connects them. So if I know, for example, in this ratio here, that each term in the first ratio is if I multiply that by 6, I'll get a term in the second ratio, then I can use that to find out what's missing. So let's take a look at our first example here. If I want to calculate the value of the unknown term, let's look at the ones that match up. Again, first matches with first. I'm going to use the colors just to help us, to remind us of this. So the green matches with the green, the blue matches with the blue. And we can see that we know both the blue numbers. If I multiply the first number by 3, then I get 36. Or going the opposite way, if I were to divide 36 by 3, I get 12, right? So what I need to do to find out what x is I need to divide 21 by 3. And in that case, x is going to equal 7. And likewise, first matches with first, second matches with second. So it's this blue one I need, and I can tell that if I multiply 5 by 6, then I get 30. So if I multiply 9 by 6, I'm going to get whatever n is. So n is going to equal 9 times 6. So I can do division or I can do multiplication. It doesn't matter. We can set up the proportion in fraction style form to solve for the missing term. We can multiply the numbers diagonal from each other and divide by number that is diagonal to the unknown term. In other words, we can sort of set it up like cross multiplication. So if I color code again, just to keep things a little bit straight, I hope. So to set this up in fraction style, I would do x over 16 equals 40 over 32. And again, I'm just going to keep with the coloring. So the x and the 40, you'll notice, are on top. The 16 and the 32 are on the bottom. That's what will happen. The first numbers go on top of the fractions. The second numbers go on the bottom when we're writing ratios as fractions. I can cross multiply. You may remember this. If I got one fraction equals another fraction, then I can just multiply diagonally. And so x times 32 is 32x. 16 times 40, well, 10 times 40 is 400. And 6 times 40 is 240. So if I add that together, I get 640. And then to isolate x, I could divide by the 32. If I divide by 32, I get rid of the 32 on the left side. If I divide by 32 on the right, it turns out that x equals 20. So that was the missing number. So let's do that for another one. First, second. C over 18, sorry, not over 18, C over 20 equals 18 over 15. Cross multiply. So I'll have 15C is equal to 18 times 20. Well, 10 times 18 is 180, so 2 times that is 360. Divide by 15, and the 15's cancel out on the left. I've got C equals, and 15 goes into 360 24 times. 5 over 60 is equal to 35 over D. Notice how the variable's in the denominator in this case. Doesn't matter if we cross multiply. Doesn't matter at all. In fact, I guess this is the first case where we got the variable in the denominator, but it doesn't matter. 5 times D is 5D, and 60 times 35 is equal to 2100. And then I can divide each side by 5. 5's cancel out. 2100 divided by 5 is 420. And the last one, (62 over y) equals 93 over 60. Again, it doesn't matter that my y is in the bottom. It's the second number, and second numbers are always in the denominator. It'll all come out when I cross multiply, and I've got, well, 62 times 60 is equal to, 3,720, and 93 times y, and I always just do it the same way. So this top number here times this bottom number here is what I always put on the left. Even though my variable is going to end up on the right side, it doesn't matter. Hopefully you understand that it really doesn't matter whether my y is on the left or on the right. Either way, I'm just trying to isolate y, so I need to divide both sides by 93. And when I divide 3720 by 93, it turns out that y equals 40. Again, I've got it written as 40 equals y, but that means the exact same thing. So that's how proportions work. Let's do a few applications using proportions. So, for a new motorbike, the recommended ratio of gas to oil is 25 to 1. All right, so that's important. That's our ratio we have to keep in mind by volume. How much gas and how much oil are needed to fill a 13-liter tank? So for a word problem, we really should do a let statement. So maybe I'll let X be the liters of gas, because that's one of the things I'm trying to find. One variable is all I need. I could let Y be liters of oil, but the less variables, the better. If I know how many liters of gas there are, if I figure that out, then I can easily figure out how many liters of oil I need. Now, a little visual might help you understand what's going on here. So I'm going to draw a little box, and this is going to represent, this box represents the gas tank. And the gas tank is 13 liters. I'm not going to, well, here, I'll write that there. 13 liters, I'll just write that off to the side. That's the volume. But if we divide this up, there's 25 parts gas and 1 part oil. So if we think about it that way, obviously the gas and the oil are mixed together. I'm not trying to suggest that they're going to be separate in the gas tank. But if I just do it by representing the full gas tank, as far as proportionally how much is gas and how much is oil, it might be something like that. So I might think of that as parts, okay? So there's 25 parts of gas and 1 part of oil. So in other words, gas plus oil equals the total amount. This idea of total amount is what we have to keep in mind. So if there's 25 parts gas plus to 1 part oil, then there's actually 26 parts altogether. That's an important concept, because I need to set up the volume is also 13 liters. Let me put it that way. So I need to set up a new ratio that gets the total amount in there. So if gas to oil is 25:1, what if I were to do gas to total? So I'm going to set up a ratio that goes parts of gas to the total amount of volume in the tank. Well, gas is 25 again, and the total, as we saw, was 26. I'm going to stick with pink for the total here. I'll still go with green just for my first number. I want to set up an equivalent ratio to that. Well, I know that the total amount of gas in the tank is 13 liters. And I already said that I was going to let X be the liters of gas. So I'm going to put X here. So now I can find out how much gas there is in the tank. I could set up a fraction. I could go 25 over 26 is equal to X over 13. Again, the parts are matching up. Colors are just meant to help us see what's going on. If I cross multiply, I get 25 times 13, which is what, 250 plus 75, so 325. Just doing this in my head. 250 plus, yeah, that should be right. 325 is equal to 26x when I cross multiply. And then if I divide each side by 26, now this might be a little harder for me to do in my head, so I'll go to my calculator. There it is. 325 divided by 26. And you can see on the right-hand side it says 12.5. So X equals 12.5. But remember, X is just the liters of gas. So now we know that there's 12.5 liters of gas in the tank. And that means for oil is going to be the 13 liters total minus the 12.5, which equals half a liter, 0.5 liters. So these are my two solutions. 12.5 liters of gas and 0.5 liters of oil. I'll write it like that. So the main thing that you need to get out of this example is this idea that even though it didn't tell me to figure out what the total parts were, I had to do that to figure out what was going on. If I tried to use I never actually did use the ratio of 25:1 in my calculations. I just used the 25:1 to set up, to figure out the fact that there are 26 parts, and then I used the 26 parts along with the 25 parts of gas. Let's do another one to see if if we can use that same concept. Camera costs $175. Ty and his brother share in the cost in a ratio of 2:3. Okay, so again, we need to know the total parts. So the total parts is equal to 2 plus 3, which equals 5 parts, right? Again, let's put that in purple. Also, this $175 on the left is the total cost. So that matches up with the 5 parts total. So I want to do a ratio. Again, let's just let X be Ty's share. And then we would have what? Ty was 2 parts. Again, Ty to his brother. Ty is the first number. So if we look at this, the order they give the words in Ty comes first, brother comes second. So that implies that in the ratio here, Ty comes first and his brother comes second. I was switching up my colors. I don't want to do that. So Ty comes first, brother comes second. Thai first, brother second, like that, just to be consistent with my colors. So Thai's parts, the Thai's share is the 2. So it's 2 to 5, if I do 2 to total, equals x to 175. So Thai's share is 2 out of the 5 total parts that are being paid. We don't know what that is. We're going to find out what that share is, but it's out of 175. So as a fraction, that would be 2/5 equals x over 175. And then we could cross multiply. And we would get 2 times 175 is 350 equals 5x. Notice how I didn't bother drawing the arrows for the cross multiply. Hopefully by this point you know what I'm doing without me drawing the actual arrows. If I divide each side by 5, what I get is 350 divided by 5 equals 70. So Thai has to pay $70, and his brother's going to pay the rest, which I guess would be 105. Each share, each part is $35. The dimensions of a rectangle are in the ratio 5 to 3. If the longer side is 18 centimeters, what's the length of the shorter side? All right, whenever they give you an option or give you a question that might involve drawing a picture, I say go for it and draw that picture for sure. So since they're talking about a rectangle, let's draw a rectangle. Okay, here's a rectangle. It's in the ratio 5 to 3. Obviously the longer side has to be the 5. But the longer side is also 18 centimeters. So I'll just write that in brackets. And we don't know what the shorter side is, so let's let x be the shorter, or the length of the shorter side. Oh, there we go. Shorter side. So that'll be x centimeters. Notice how I don't need total parts in this case, because we're not talking about the full perimeter or anything like that. We're just comparing short side to long side. So we don't always have to find total parts. We have to pay attention and see what makes sense. So in this one, it would be 5 to 3 is equal to 18 to x. Again, matching up one green and one blue in each of the ratios, making sure that the order remains the same, that I don't switch the order of anything around, because if I do that, I'm definitely going to get the wrong answer. If I cross multiply, I get 5x is equal to 54, and then I divide each side by 5. X's cancel out, and 54 divided by 5, well, 50 divided by 5 is 10, and 4 divided by 5 is decimal 8.8. So as a decimal, it's going to be 10.8, and the units were centimeters. So the short side is 10.8 centimeters. To make orange juice from concentrate, you use concentrate and water in the ratio of 1 to 3. Okay? Concentrate, water, 1 to 3. How much concentrate do you need to make 1 liter of orange juice? 1 liter of orange juice is the total amount, right? So this is 1. It doesn't talk about the concentrate. It doesn't talk about the water, like how much of each we have. It just gives us the total amount. That's why I've highlighted that in purple. For this lesson, I've just made purple be my color for total amount. So that means I need to find the ratio, total parts. So total parts is 1 plus 3, so there's 4 parts altogether to make up 1 liter of orange juice. So if we let x be, what do we need? How much concentrate and how much, so it doesn't really matter. I need to get concentrate and water. So let x equal amount of concentrate. So that would mean that I need to do 1 to 3 is equal to x to 4. Is that right? No, I did that wrong. Got to slow down a bit. 1 to 4 is equal to x to 1, and that's 1 liter. That might be confusing. So the one on the left, this one matches up with the one that I've marked in green. The other one on the end is the 1 liter. I'm actually going to put the unit on there in this case, just so it's to avoid confusion. X is my concentrate, 4 is my total parts that match up with the 1 liter. So 1/4 equals x over 1, cross multiply, I get 1 equals 4x, divide each side by 4, and x equals 1/4 or 0.25 liters of concentrate, and therefore we need 1 minus 0.25, which equals 0.75 liters of water, because the rest of it has to be water, doesn't it? So these are the two things that we were asked to find. One more example. Oh my goodness, 2 more examples. So many examples. Anyway, I'll go through them fast, but if I'm going too fast, you know that you have the option of always pausing or backtracking at any point. A punch is made with orange juice, lemonade, and ginger ale in the ratio of 2 to 3 to 10. All right, we've got 3 different things going on here. So I'm going to do in the same order that I have. So orange juice, or the first number is in green, the second number is in blue, and the third number is going to be in orange. I realize that I could have changed the colors up and made the orange juice orange and the lemonade yellow, but I want to stick and be consistent. Ginger ale, because there's a third number in the ratio being introduced, I introduced this third highlighter color. And it's going to make a total of 75 liters of punch. So total I'm going to keep as pink. So total parts, again, we've done this enough times now, we know that if we add these parts together, then we'll know how many parts are in total. 2 plus 3 plus 10 equals 15 parts. How much orange juice and lemonade and ginger ale are needed? So I can only do one thing at a time. So I'm going to set up a ratio. I'm going to set up a ratio of orange juice to total to start with. So 2 parts orange juice to 15 parts total is equal to, and I'm going to let x be the amount of orange juice, OJ for short. So 2 to 15 is equal to x to, 75 liters. Fraction, cross multiply, 150 equals 15x. Well, that's easy then. If I divide each side by 15, I get 10. So x equals 10 liters of OJ required for this punch. I'm going to have to do a second let statement because there's still 2 more things I have to find. So maybe I'll let y be liters of lemonade. And in that case, lemonade was in blue, wasn't it? So in that case, I would have 3, because that was my parts for lemonade, to 15. So lemonade parts to total parts is equal to y to 75 again. Again, fraction, cross multiply, 225 equals 15y, divide, and y ends up equaling, what is that, 15 times it goes into 225. So, yes, 15 times 15 is 225. So liters of lemonade. So that's the second part. And then we need ginger ale. So we need, I don't have a lot of, oh, I guess I can do it over here. So ginger ale we could do 75 minus 10 liters of OJ minus 15 liters of lemonade equals 50 liters of ginger ale. So if we have 3 parts in a ratio, we can only ever work with 2 parts at a time. So this is kind of an interesting question because you can see how I added things up, but when I worked with them, I broke it down to just made it into 2-part ones where I compare 1 part to the total parts. Last one. In a taste test, 14 out of 17 people preferred unspiced salami to spiced salami. A total of 1,500 kilograms of salami are being processed. Find the amount of spiced and unspiced salami that should be processed to the nearest 10 kilograms. Okay, so 14 out of 17. Okay, out of 17. The 17 actually means that that's the total number of people, which should match up to the 1,500 total kilograms. So, in this case, I want to let X be the kilograms of unspiced salami and that means that I would do 14 to 17 is equal to X to 1,500. Fourteen over 17 equals X over 1,500. Just make sure that everything looks right when I put it in fraction form, but it does to me. If I cross multiply, then what I get is, let's see, I guess it's hard. I'm just going to go to my calculator. Up till now I've been doing stuff in my head, but I'm feeling lazy. So 14 times 1,500 equals 21,000. Okay. So 21,000 equals 17x. And then I'll divide each side by 17. And so 21,000 divided by 17 equals 1,235.3 kilograms. Now I'm supposed to round to the nearest kilogram. So nearest kilogram, nearest 10 kilograms. So I need to look in the tens column. There's a 3 in the tens column. That means that's what I'm rounding to. So then I look to the column to the right, the ones column, since if it's 5 or above, I round up, and it is 5, I'm going to round up. I round this up to 1,240 kilograms. So I'm going to round that 3 up to a 4. And so I have X is approximately equal to, that little dot over the equal sign means approximately equal to 1,240 kilograms of unspiced salami. And then I'm supposed to also say how much spice there is, but again, that's easy. If there's 1,500 kilograms in total and I've got 1,240 of unspiced, then that means that there must be 260 kilograms of spiced salami. Pardon me, spiced. And that's it. It's kind of a long lesson. I tried to go through it quick. And again, if it was too quick, just go back and review anything that you had trouble with. Good luck.